Hello everyone, welcome back to a lecture series of GATE in Data Science and AI. So in this lecture, we are going to discuss about the propositional logic. This is part B, okay? So part A we already discussed in the previous video. So in that we have discussed about various type of operators which we used in the propositional logic along with the truth tables and example, okay? So please watch that video before watching this particular video, okay? So this is what we have discussed in the last video, that is part A, that is precedence of operators. So we have different operator. This is not operator, this is and operator, this is or operator, this is implication, this is implies, this is bidirectional, right? So this all we have discussed in the previous lectures, and this is the precedence of the operator, okay? And this is the how we use this precedence of operators. Say for example, if we have to solve this particular expression, so first we'll take the negation and then we'll take the and. Here also first we'll take the and operator. Now here we first perform the AND operation between P and Q, then we'll take the implication with respect to R, right? So this is how the precedence of operator works. So this thing we have discussed in the previous lectures up till this point. Now let us take few examples. Okay, so let us consider propositional P in this. So Alice is smart and propositional Q is Alice is honest. Okay, so we already discussed this example in the previous lecture. Suppose this expression is given to us, negation of P and Q. So what to say about this? So first, negation of P will be performed, that is Alice is smart, which is P. So negation of P will be Alice is not smart, right? But honest, right? It is and operator, so we can say Alice is not smart and honest. So if we say Alice is not smart and honest, it will be different thing. But Alice is not smart but honest. So you have to select the appropriate statement based on the given propositional logic. Okay. So here also P, then R, then inside the bracket negation of P and Q, right? So first bracket will solve, right? And in that bracket also first we'll solve for this particular negation. So same thing. What will happen here? This is same thing, right? This and this are the same thing, right? So Alice is not smart but honest. Now here you can see just take P, okay? That is Alice is smart. So Alice is smart or Alice is not smart but honest. So what we can say in short, either Alice is smart or she is not smart but honest. Okay. So here if you observe, this is suppose my uh, R, right? So P or R we are saying, and what is P here? Alias is smart. So either Alias is smart or this is or symbol, or she is not smart. So she is not smart but honest. This will be my R, right? This is my R actually, right? So first we solve this bracket, then we come to this particular conclusion, and then we have solved this P or in the bracket negation of P and Q. Okay, so this is what we will get. And what about this P implies negation of Q? So first negation of Q will solve. So what is negation of Q? Q is Alias is honest. So negation of Q will be Alias is not honest, right? So Alice is not honest, right? Alice is not honest. So what P implies negation of Q here? If Alice is smart, that is P. If Alice is smart, then she is not honest, right? If Alice is smart, she is not honest, right? So this is the equivalence in the English language of this particular expression, right? So this type of questions you can expect in the exam. They will give you some sentences, and based on the expression, you need to select the correct options, or vice versa can also be true. They will give this proposition first. They will give these particular sentences, and based on the sentences, you need to select the correct logical expression, right? So either way, they can ask the question. So please try to practice for this. Okay. So it is not that difficult, very easy, but you just need to practice few examples, then that is fine. Okay, then you can do it very easily. Okay. Okay, so that's what we have discussed. So we can also go in other directions, translating English sentences to the logical formulas, right? So what we have discussed now, translating the logical formulas to English sentences, but we can also look at for translating English sentences to logical formulas. So this type of question can also be asked in the exam, right? So first is Alice. Alice is either smart or honest, but Alice is not honest if she is smart, right? So this will become complicated, right? How to break down this particular statement in this, right? So first see, Alice is either smart or honest, right? Just take this particular example, okay? Right? And this take but Alice is not honest if she is smart. So by looking at this particular sentence, you can come to know, okay, Alice is not honest if she is smart, right? If you remember in the previous lecture, we have discussed about few terminologies in the implication, right? So if such type of sentence comes, we should know, okay, we have to use implication in this particular sentences. But right? But which are those, right? So P or Q first, right? So Alice is either smart or honest. So what is P here? Alice is smart and Q is Alice is honest. So P is either, so Alice is either smart or honest. So from this I can say P or Q, right? P or Q. But Alice is not honest. And here it is Alice is honest. So that is basically negation of Q. So this sentence will give me negation of Q, right? Right? And if she is smart, so she is smart is basically P. So this is P here from here to here, right? So also it is if there, that means there is implication. Now if you remember terminologies, what we have discussed, P implies negation of Q. Okay, so from this we can say P implies negation of Q. Okay, so and if you combine this with the help of but, because but will ensure that this and operator will be considered. So this can be a possible expression, that is P or Q, then and P implies negation of Q. So this is the correct representation of a particular English sentences. Okay, so you need to break down the English sentences with respect to your given proposition, that is P, Q or R in any case, and then based on that you need to formulate the expression. Okay, so let us look at this one more example here, that Alice is smart is necessary and sufficient for Alice to be honest, right? Necessary and sufficient for Alice to be honest. So if you remember the slides that we have discussed in the previous lecture, okay, so first let me go back to that particular slide. Okay, so I'm talking about this particular slide. Okay, so this is a terminology for implication, right? So in the first question, we have to use this Q if P. What we are saying, P is sufficient for Q and Q is necessary for P. Okay, if both the conditions are there, then it means it is used for bidirectional, right? Here you can see P implies Q and Q implies P. It means it is equivalent to P bidirectional Q. So if we apply the same logic here in this case, what I will get? P implies Q and Q implies P. Okay, so that Alice is smart is necessary for Alice to be honest. That will be P implies Q. Alice is smart and sufficient for Alice to be honest. That is basically Q implies P. So an operator will join so an operator will join these two sentences, right? So we can say this is the equivalence of the English sentences, and we know if P implies Q and Q implies P, then this is equivalence to bidirectional implication. Okay, so this is the correct answer for that. Okay, so I hope you understand this particular concept of propositional logic, how to convert the English sentence to logical formulas and how to convert logical formulas to English sentences. So this type of questions you can expect in the exam, so please try to practice. I have come up with few questions, so you need to practice that and that will be enough. Okay. Okay, now we'll discuss about the tautology and logical equivalence. So what is tautology here? A compound proposition that is always true is called as tautology. Two propositions P and Q are logically equivalent. When P and Q are logically equivalent, if their truth tables are same, it's very important. If their truth tables are same, then we can say P and Q are logically equivalent. Namely, P and Q are logically equivalent if P bidirectional Q is a tautology, right? If P and Q are logical equivalent, then we can write P, and this is the equivalent symbol. This three horizontal lines, we can say it is a equivalent symbol. So P is equivalent to Q. Okay, and the condition is for that is P bidirectional, Q is tautology. So tautology means for all the cases, the value of this particular expression will be T. That is true. Okay, it's always true. Okay, so we'll discuss with the help of few examples now. Okay, let us take this particular example. Look at the following two compound proposition. Okay, so first is P implies Q and Q or negation of P. Okay, so if we draw a truth table for both the cases, so first P and Q, T T, T F, F T, F F, and here is the truth table of P implies Q. Okay, like this. And same for this particular thing. PQ, then negation of P is there. So negation of P, it is simply opposite of true, false, false, true, false, true. And just take the OR between these two rows, these two columns, right? So what you will get T, F, T, T. So if you observe this truth table and this particular column are same, then we can say this and this are logically equivalent, right? The last column of two truth tables are identical. Therefore, P implies Q and Q or negation of P are logically equivalent, right? So P implies Q, bidirectional implication. Q implies negation of Q or negation of P is tautology. Okay, so thus we can say these two are equivalent. Okay, suppose in the question you ask for like which of the following is equivalent to this particular expression, so you need to draw the truth table and try to compare, right? So it will take your time, but there is one more shortcut for that. For that you need to understand few rules. Okay, based on that you can just simply prove which are the equivalents, or if this is suitable for you, you can directly go through this, just draw the truth table and try to find out whether both the truth tables are same or not. Okay, so that will be the case. Okay, so I hope you understand this particular example. Okay, so first this is De Morgan law. So if you remember, I have given this expression as a homework in the previous lecture. Okay, so we have to prove that negation of P and Q is equivalent to negation of P or negation of Q. Okay, same thing we can also say negation of P instead of and or Q is equivalent to negation of P instead of or it is and negation of Q, right? So both the laws, it's very important law. It can be useful to solve the complex logical formulas, logical expressions. Okay, so it will be useful for you. So please remember this very important law, De Morgan's law. The following is truth table proof for one. So here you can see the proof, uh, like T, 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 F, F, T, and for each of the cases we have solved. We have given the truth table. Now, if you observe this column and this column, they both are identical, right? Then we can say this is the equivalent. Both the expressions are equivalent to each other. Similarly, we can prove for this rule number two, this law number two. Okay, so this is the solution for your previous homework question. This is basically that homework question. So try to compare with your solution. Okay. The next law is distributivity. Okay. So what does it tell us? Suppose P or inside the brackets Q and R, then what we can say P or Q and P or R. Okay. Very important. Very important. Okay. De Morgan law is the very important, and this is also very important. So P or inside the bracket Q and R, it is equivalent to P or Q and P or R, right? So same thing in this case also, instead of just an operator, all operators are used in this case, right? But this thing is same. So please you need to remember this basically logical rules. Okay, very important things you need to remember anyhow. Okay, so nothing much complex. If we multiply with the bracket, so P or Q and P or R, right? So P or Q, then P, and after that P or R. Okay, so this is the equivalence of this particular expression. So please try to remember this, and this is the proof for this particular expression. Okay, so try to solve by your own and then you can compare with the given solution. Okay, right? So what is contrapositive? The proposition negation of Q implies negation of P is called as contrapositive of the proposition P implies Q. Okay, and they are logically equivalent also. So P implies Q is equivalent to negation of Q implies negation of P. Another very important point to note. Okay, another very important point to note, and this is the proof for that. Okay, so I am not going in detail. I think you can easily do this, right? So you can just compare these two columns, and also it better if you try to solve this proof by yourself. Okay, so please note this particular contrapositive rule. Okay, so these are few equivalence laws or rules you can say in the propositional logic. Okay, so P and true always be equivalent to P. P or false, it is equals to P. P or true is equivalent to true. P and false equivalent to false, right? Because it doesn't matter, because they are using an operation. So either P can be true or false. It doesn't matter because any one of the case is false. Then it is equivalent to false only, right? So these are the names. So you don't need to remember the name, but yes, these are the few equivalents. So you just need to go through it. So importance are distributive law, De Morgan's law, absorptional law, okay, negation law. So just go through it once. Nothing much to remember in that. It's a simple thing. You just need to read it 2-3 times. Okay. So I'm not going in detail. You just have to remember this. That's it. Okay. Then the logical equivalence involving conditional statement, that is basically a P implies Q. Okay, this thing. So P implies Q is equivalent to negation of P or Q. P implies Q is equal to negation of P implies negation of Q. So this is what we have discussed. That is contrapositive, right? And same thing you can see for others equivalence rule also, right? But if you observe this first few are important, and the rest you can directly prove based on what we have discussed just now. Okay. Also, this many of these particular rules can be proven based on the whatever we have discussed just now, like by using De Morgan's law or distributive law, right? So it depends. So try to go through it once. Okay. So better to go through it once because we don't have time in exam to solve with the help of truth table. Okay. So all these laws can be very useful while solving the complex logical problem. Okay. Now, this logical equivalence involving bidirectional statement, that is bidirectional statement, yes. So P bidirectional equivalent to Q. So P bidirectional Q is equivalent to P implies Q and Q implies P. So this also we have discussed, right? And this also we have discussed, right? So please try to keep a note of this particular expressions, equivalence rule. So like for all the three slides what we have discussed today, okay? Because these all are very important, right? Based on this only you can solve many questions, right? So these three slides you need to remember. Try to read multiple times. It is easy. So if you try more and more questions based on this particular topic, you will be easy to understand the logic behind this particular rules. Okay. Okay, so this is one example. We need to prove whether this and this are equivalents or not by using various types of laws. Okay, so in the first cases, we have used truth table, right? Truth table to verify whether this is equivalent to this. You can also follow that to draw truth table for this particular case, and after that, this case, and see whether we are getting same truth table or not. But it will take much time to do that, right? Because they have lot of conditions here, right? So how to solve by using various laws? That's what we have discussed today, right? So first let me write it down. Negation of then in bracket P or negation of P and Q in bracket and bracket close. So this is negation of P, right? So can I use De Morgan's law here? So what is De Morgan's law? What is De Morgan's law here? So negation of P or Q is basically negation of P and negation of Q, right? Can I apply the same here? Yes, I can apply. That is negation of P and negation of this particular bracket, right? That is negation of P and Q, right? Now this negation of P as it is. Now, again, can I apply De Morgan's law here? Yes, of course. That is negation of P instead of and it will be or negation of Q, right? So negation of P will be P itself, right? So negation of P and negation and P, that is because it is equal to P and sorry or negation of Q, right? Okay. And this is bracket here, right? Now tell me what I can do after this. It's also bracket, right? So we have distributive law also, right? Distributive law. We have discussed this. So by using this distributive law, can I apply here? Yes, of course. So what is that? Negation of P and P. Okay, this will be my one bracket and it is or. So or then negation of P and negation of Q. This will be my one more bracket. Okay. Now what this negation of P and negation of P will give me? Tell me. Right? Suppose P is false. Okay. P is false and negation of P will be true, right? If P is false and negation of P will be true, or you can consider vice versa also, like P is true and negation of P will be false, then what is false and true here in this case? False and true will always be false, right? So I can say this is false, right? Or negation of P and negation of Q, right? Now if you observe here, false or anything, right? False or anything, it can be true, so it will be true If false or it is false, then it will be false, right? So in either of the cases, it is or operator, right? If whatever is present on this particular side, we can consider as it is, right? Right? So false or anything along with it, basically a true or false itself, right? So I can compare, I can write it as negation of P and negation of Q here, right? This is what we have to prove. So, so please keep a note of this particular point. False or it can be anything. It can be true or false. The answer will be this particular side, true or false, right? It depends on this particular side. If it is false, then false. If it is true, it is true, right? So we can consider like this, right? Right, so in general I can say F or R is equivalent to R for any R. It can be true or it can be false, right? So based on this only I can conclude that negation of P and negation of Q is there, right? So this is the equivalent. So this is how we have to prove, right? So in exam also you will be able to, so in exam also you can expect such type of questions, not for proof, but which of the following expression is equivalent to this particular expression, right? So in that case you need to apply these particular laws. Okay, so I hope you understand the concept of a propositional logic. There are few important parts are remaining. So this is just the introduction to propositional logic in general, but few more concepts are required in the case of AI part. So that's what we are going to discuss in the next lecture. So in order to practice this particular laws and propositional logic, I have added 10 questions on the website. Okay, so let me go to website. I will show you. Yeah, so this is our website, piyushwairale.com. So in the AI course, you can see in the AI course, in the propositional logic part, I have uploaded the two videos and this PDF you can see, right? So here you can see the questions. Just try to solve those questions, okay? Try to solve these questions. There are total 10 questions, I guess. Yes. This is the first two questions, right? And then we have this type of questions, right? You need to prove the truth table by using truth table also, or try to prove using the laws we have discussed. Okay, and here in this question you have to show that okay, this particular expression is implies to Q is a tautology or not. It means that for all the cases we are getting true value or not. Okay, so please try to solve this particular questions. Okay, I will publish the solution after 3 days. Okay, so that's it from my side. Thank you.